Hello friends and dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is the set 1 video of 5 good problems on the chapter of area of polygons, where in this playlist I solve relatively harder problems from each chapter as and when they are completed in the other playlist, that is CBSE Maths 8 R.S. Agarwal. So this video is part of the playlist Maths 8 Hot. Hot HOT stands for higher order thinking, which requires a little bit of thinking to solve the problems. If you are new to my channel or not yet subscribed, and if you are watching my videos in the other playlist, that is CBSE Maths 8 R.S. Agarwal, and this playlist, that is Maths 8 Hot, and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 1 on the chapter of area of polygons. Okay, so I have the set of problems on the left hand side. I hope the fonts are big enough so that you can read them properly. On the right hand side, I will solve the problems. After solving the problems, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. But always try to solve the problems yourself first. Ideally, so there are 5 problems. Ideally, you should be able to solve these problems in 30 minutes. That is taking 6 minutes to solve per problem. When you are stuck, or if you want to see my way of solution, you can always see this video. But please also note that there is not a single way of solving a problem. A mathematical problem can be solved in multiple ways. It is not mandatory that you stick to my way of solution. I will just provide just one way of solving the problem. You might be having a better way of solving it. That is totally fine. Okay, so let's get started in solving the problems. Question number 1. So a figure is given. We can see before reading the figure, before reading the problem, more or less we can see that there is a triangle, there is a rectangle ABCD, and inside there is another rectangle EHGF. Okay, and the vertices of vertices of the inner rectangle are connected to the vertices of the outer rectangle, and obviously we are having the sections in between the two rectangles as a trapezium. We have 4 trapezium. Okay, so now let's see what the problem is saying. EFGH is a rectangle inside the rectangle ABCD. AB is equal to 4x. AB is equal to 4x. AB is equal to 4x. AB means okay. Okay, so we can see that the length and breadth of the rectangle ABCD are both same, so it must be a square. So AB is 4x, AD is 4x, and the uniform gap between the two rectangles is x. So as you can see, the gap between the two rectangles is uniform, which is x. This also means that the inner rectangle EFGH is also a square, and its side will be 4x minus 2x, since each gap is x. Okay, let A1 A2 be the area of the quadrilaterals ABHE. ABHE is a trapezium, as we can see, and EFGH is the inner rectangle or inner square respectively. Okay, if A1 is equal to k% of A2, then the value of k is. Okay, so basically we have to find what percentage is the area A1 of A2. If we can find that, then we have found k. Okay, let's do it step by step. So basically we have to find ultimately A1 and A2. What is A1? A1 is the area of quadrilaterals ABHE. Now I will not draw the diagram. I will simply simply write the steps of the solution, referring the diagram from the problem PDF. Okay, What is A1? A1 is the area of the quadrilateral ABHE. So ABHE is clearly a trapezium. So in trapezium ABHE, we can see that the sum of parallel sides, sum of parallel sides will be equal to, the smaller parallel side is EH and the larger parallel side is AB. Now what is EH? What is EH? EH is, since the gap between the two rectangles is same, which is x, it must be the length of the side of the outer rectangle ABCD is 4x minus 2 times the gap, so 2x. This is EH. And what is AB? AB is 4x. This is equal to 6x. So for the trapezium ABHE, the sum of parallel side is 6x. And what is the height? Height of the trapezium ABHE, it will be definitely the inner gap will be equal to the gap between the two rectangles, which is equal to x. So this implies area. I am in short writing AR for area of trapezium ABHE will be equal to, we know, half multiplied by the sum of the parallel sides, which is 6x, multiplied by the height or the altitude, that is the distance between the parallel sides in a trapezium, which in this problem is x. So this is 3x square. 3x square is the area of the trapezium ABHE. Okay, now this is A1. So this implies A1 and A2 be the area of the quadrilaterals ABHE. So we have A1 is equal to 3x square. Okay, now we have to find what is A2. A2 is the area of the quadrilateral EFGH, that is the inner square. So clearly area of EFGH is equal to, since it's a square, it will be the side of each side of the inner square is 4x minus 2x, this square, this is equal to 2x square, which is equal to 4x square. Okay, so this implies this is the area A2. So we have A2 is equal to 4x square. So now what is k percent of A1 is k percent of A2. So to find k, we must find what percentage is A1 of A2. This question we must answer or solve. So this will be equal to A1 by A2 multiplied by 100. Okay, so this is equal to A1 is 3x square, A2 is 4x square multiplied by 100. So x square will cancel out, and this will be and 4 will divide 100 with 25. So this is clearly 75 percentage. So this implies that A1 is equal to 75 percentage of A2. Now it is given that A1 is equal to k percentage of A2. So this clearly we can now say that k is equal to 75. K is equal to 75. So the correct choice is D. D is the correct choice. Okay, let's do problem number 2. Problem number 2. uh, okay, the parallel sides of an isosceles trapezium are in the ratio 1:5 and its area is 18 meter square. If the altitude is 5 meter, then the length of each non-parallel side is. So let's quickly draw an isosceles trapezium roughly. An isosceles trapezium will look like this. So these are the parallel sides. Let's say the trapezium is ABCD, where AB is parallel to CD and AD and BC are the non-parallel equal sides. Okay. The area of the trapezium is given, the ratio of the parallel sides are given, and the altitude is also given 5 meter. Okay. So the altitude, as you know, if I drop a perpendicular from B on DC, this will be the altitude of the trapezium. Let its length be h. Okay. Now, since the ratio of the parallel sides of the isosceles trapezium is given to be 1:5, let based on the ratio, let AB is equal to x and DC will be equal to 5x based on the concept of ratio and proportion. Okay. Now the altitude is already given, is 5, h is 5 meter. Also the area is given as 18 meter square. Now altitude is given, area is given, we can clearly find the sum of the parallel sides. So area, in short, area ABCD, area of trapezium ABCD will be equal to a half multiplied by the sum of the parallel sides, that is AB plus DC, multiplied by the altitude h. So this will be equal to half multiplied by AB plus DC is x plus 5x and the altitude is given to be 5 meter. So this much meter square. So this is equal to 6x by 2 multiplied by 5 meter square. This is equal to 15x. 15x meter square is the area of the trapezium, where x is the unknown multiple in the of AB and DC. Okay. Now area is also given. Area of the trapezium is also given to be 18 meter square. So we must have 15 x should be equal to 18. This implies x will be equal to 18 by 15, which is equal to 6 by 5. X is x is 6 by 5. Then the length of each non-parallel side. So if the length of the each if the length of each non-parallel sides be a, we have to find a. We have to find a. Okay. So we know that in an isosceles trapezium ABCD, if we drop another perpendicular from A on DC, so this will also be h, and this and the triangle AD, let's say this be BE and AF, the triangle ADF, from the properties of an isosceles trapezium, triangle ADF will be congruent to triangle BCE. This will imply that area of two congruent triangles are equal. So area of the triangle ADF will be equal to area of triangle BCE. But this was not required. The thing that we need is EC. We have to somehow find A. It has asked the length of each non-parallel side is, we have to find A. We know height, altitude. If we know EC, we can find A. Now, okay, let me first find. Let me quickly. Okay, so x is 6.6 by 5. So this implies that AB is equal to 6 by 5. 6 by 5 meter, and CD or DC is equal to 5x, that is 5 multiplied by 6 by 5 a meter. This is 6 meter. This is 6 meter. Uh, the height is 5 meter. The ratio is 1:5. So x plus 5x, 6x, 3x, 15 meter. And if the altitude, if the area is 18 meter square. Okay. Okay, fine. So we have this. Now, please note that in triangle, from the properties of isosceles triangle, we can easily see the in the triangle BEC, what will be AC? EC. EC will be DC DC minus DE. DC minus DE, which is equal to DC minus, what is DE? DC minus DE. Okay. Now, what is now if we consider from the properties, since triangle ADF and BCF are congruent, if I consider this to be D, this will also be D, DF will also be D. So we will have DF is equal to EC equal to D. Let we are assuming D to be EC. The length of EC or DF is equal to D. Now, so we will have we can easily find D from the fact that DC is equal to DF plus FE plus EC. This implies DC is what? DC is 5x. So DC is 6 meter. So DC is 6 meter. So we have 6. 6 is equal to DF is D. We have considered both DF and EC, their length to be D. So we will have D, and what is FE? FE will be equal to AB, and AB is 6 by 5. AB is 6 by 5. FE is equal to AB, which is 6 by 5. We have already found x to be 6 by 5 and AB was x, and we have plus D. So this implies twice D is equal to 6 minus 6 by 5. This is equal to 24 by 5. This implies D is equal to 24 by 5 multiplied by 1 by 2, which is 12 by 5. D is 12 by 5. Okay. I'm not sure whether I am doing any kind of calculation mistake or not, but somehow I'm getting a feeling that my answer will not match with the given choices. Anyway, let's proceed. So we have found D to be 12 by 5. Now, in the right angle triangle, so BEC is a right angle triangle. Using Pythagoras theorem, we can now easily find A, because we know H is 6 meter, it is already given. H is 5 meter, it is given. And we also know EC, which is D, which is 12 by 5 meter. So in triangle BEC, we already have in triangle BEC, we will have A square. That is, if we consider the length of the each non-parallel equal side is A, we will have A square is equal to H square. H is the height of the trapezium plus EC square, or rather D square. D square. This is equal to H square is 5. H is 5 meter, so 5 square plus D is 12 by 5. 12 by 5 square. this is 5 square. So this is 25 plus 144 by 25. This is equal to 625 plus 144 by 25. This is equal to 789, not 789 but 769. 769 by 25. No, it will definitely not match with the given choices. I might have done something wrong in the calculation, or the choices are given wrong. I will once again quickly check. The parallel sides of an isosceles trapezium are in the ratio 1:5. Okay, so x and 5x. The altitude is given is 5 meter and the area is 18 meter square. So the area of the trapezium will be half into sum of the parallel sides AB plus DC into h, so which is half into x plus 5x, which is 6x multiplied by 5. So we have 3x, 6x by 2, which is 3x, 15x meter square is the area of the trapezium. I think in the problem it could be that the area should have been given as 15 meter square. I think there is a mistake in the problem. It is given as 18 meter square. I'm really sorry for this, because the answer is coming really weird. I mean by weird I mean the a will not be an integer. If I first of all, the square root of 769 by 25, 769 I don't think is a perfect square. Sorry friend, I'm using the calculator. 769 is definitely not a perfect square. So this a will not come as a integer. All the choices are given as integer. Let me see if I consider the area to be 15, then we are getting as 1, x is 1. So this will imply that AB will be x, AB will be 1 meter, AB will be 1 meter, and DC will be this is 1, so this is DC will be 5 meter. This is DC is 5 meter and AB is 1 meter. Then we will have FE will be, FE is 1, FE is AB is 1, so this will be 1, this will be 1, and we will have twice D. DC is what? DC is 5. DC is 5. So we will have here 5. So D, so twice D will be equal to 5 minus 1. So this will D will be 2. D will be 2. D will be 2. So if D is 2, now we can find what will be A. So A, H is H square, H is altitude, which was given as 5 square, and D is 2. Still we will not length of each of the non-parallel side. Okay. So what is D coming? D plus FE, FE is AB and AB is X, and X is 1. So FE must be 1, and DC is 5x, X is 1, so DC is 5 meter. Okay, so 5 is equal to twice D plus 1, so twice D is equal to 5 minus 1 is 4, so D is 2. Okay, D is 2. This is equal to 25 plus 4, which is 29, which is not a perfect square, which is not a perfect square. H was given as 5 meter. Anyway, so I think the data is given incorrectly in the problem. The more important thing is how we are solving the problem, the steps and the concepts being applied. So this implies A will be square root of 29, considering the fact that the area of the trapezium is given as 15 meter square. As so we see that none of the choices are matching. So this problem was a little that the information given in this problem was not actually correct. I'm sorry for this, but please focus in the solving approach of the problem. Okay, let's do the next problem. Problem number 3. So a figure is given. Now in this figure, AB is 12 centimeter, BC is 3 centimeter, BC is 3 centimeter, ED equals to EF, ED equals to FE is equal to GF is equal to AG equals to 4 centimeter. Then the area of the ABCD EFG. I think it's better we need to draw the figure. So this is AB, then we have, so this is 4, AG is 4, okay, GF is 4, okay, FE is again 4, okay, so GFE, F is 4, ED is 4, ED is 4, and we have this is 3. Remember, BC is 3, it is not 4. So the point C and G will be vertically on the same line. So BC is less than AG. So we have this figure. Okay. So this is 4. I'm not writing the unit. So this is 4. This is 4. This is 4. This is 4. This is 3, and this is 12. Okay. Now definitely we have to divide this figure into some rectangles or triangles and trapeziums or squares, whatever. These are the primary figures that we have to construct to find the area, depending on what dimensions we have. Okay. This is 4. Okay, this is 4. Okay, fine. Now if I draw, so definitely we can see from the given figure that these are all right angles. These are all right angles. These are all right angles. Okay, so if I draw a line parallel from D, if I draw a line parallel to AG, FE or BC, that is a line perpendicular to the side AB, and also let's say I extend the FE, the side FE to meet the side AB at I. So this will also be perpendicular. So now I can see that the entire figure is divided into the topmost part is a square, that is AGFI. AGFI is a square, since AG is equal to GF is equal to 4, and also we will see that AI is also equal to 4, because AGFE is, first of all, AGFE is definitely a rectangle. So definitely AI will be equal to GF. So what we have done is we have draw DH perpendicular to AB. and extend FE to meet AB at I. So this will imply that AI will be equal to GF will be equal to 4 centimeter. Okay. Also, what will be IE? IE will be equal to IF plus FE, which is equal to 4 plus 4 equal to 8 centimeter. IE is equal to 8 centimeter. Also, this will imply that HD is equal to IE, since DH will be a rectangle. IE equals to 8 centimeter, and the bottommost part, the bottommost figure is a trapezium where HD is parallel to BC and the height is HB. The height is HB. So in trapezium HB CD, we have HD parallel to BC. These are the parallel sides, and height is equal to HB, which is equal to which will be equal to the entire side, that is AB minus AB minus AI minus IH, which is equal to AB is 12 minus AI is 4, and IH is equal to ED, which is equal to 4. So this will also be equal to 4 centimeter. Okay, so now the area of the figure, that is A, B, C, D, E, F, G is equal to area of the square AGFI. AGFI is a square plus area of the rectangle IEDH. IEDH is a rectangle plus area of the trapezium HBCD. Okay, so this will be equal to, what is the area of the square AGFI? It is the each side length of the square AGFI is 4 centimeter. So this is 4 square plus what is the area of the rectangle IEDH? It will be IE is 8 multiplied by the length of the rectangle IEDH is 8 and the breadth is 4. So this much, 8 into 4, plus the area of the trapezium HBCD will be half multiplied by the sum of the parallel sides, that is BC plus HD. BC is 3, is given as 3 centimeter, and HD is equal to IE, which is 8, and the altitude is the altitude of the trapezium is BH, which is 4. BH or HB is 4. So the total area is this much centimeter square. So this is equal to 16 plus 32 plus 8 plus 3 is 11, and so this is 22. This much centimeter square, and this is equal to 48. 48. So 70 centimeter square is the area of the total figure, and hence the correct choice is B. B is the correct choice. So the important concept was to observe the figure, what dimensions are available, and how you will divide the figure into rectangles, triangles, or trapeziums or squares, and find, so that you can find the area of those individual trapeziums and rectangles or triangles or parallelograms and add their area. the tricky part was that it was important to note that AG is not equal to BC. BC is shorter than AG. So if you definitely if you extend the GF, it will not meet C. It will not meet the point C, and hence it was necessary to divide this entire figure in this way. It could be possible that you can divide this figure into some other smaller figures, maybe some other rectangles or squares or trapeziums. I'm not aware of that, but I think this will be one good solution of this problem. Okay, let's see the next problem. Question number 4. A figure is given. So in this polygon, so ABCDE is a polygon. AG is perpendicular to BE. Okay, so BE is definitely a diagonal of the figure. AG is perpendicular to BE. DF is perpendicular to BE. HC is perpendicular to BD. So BE and BD are two diagonals. Okay, AG is given as 2 meter. AG is given as 2 meter. FD is given as 8 meter and HC is given as 3 meter. So the length of all the perpendiculars are given. The area of triangle BED, is 40 meters square. Okay, if the ratio of area of quadrilateral ABDE and BCD and triangle BCD is 5:2, then length of BD is. We are given the ratio of the area of quadrilateral ABDE and BCD, then the length of BD is. Okay. So definitely we have to find somehow the area of triangle BCD. If you know the area of triangle BCD, we know its height is HC. We can easily find BD. Okay, let's do it step by step. The area of triangle BED is given. So the area of triangle BED will be equal to half. We can say half multiplied by BE as the base, BE multiplied by FD. This is equal to half multiplied by BE, we do not know, BE we do not know, but FD we know, FD is 8 meter 8. So this implies that area of the triangle BED is given to be 40. So we have 40 is equal to, on the right hand side, half BE into 8 is 4 BE. 4 BE. 4 BE means 4 multiplied by BE. Okay. So this implies that BE is equal to 40 by 4, 40 by 4 meter, which is equal to 10 meter. So BE, the diagonal BE is 10 meter. Okay. The ratio of area of quadrilateral ABDE, the quadrilateral ABDE. Okay, so ABDE. Okay, if we know BE, we can say area of triangle ABE. Area of triangle ABE will be half multiplied by the base. We can consider BE and the height is AG, which is equal to half multiplied by BE. We have already found to be 10 and AG is given to be 2. So this much meter square, which is equal to 10 meter square. So this implies, we can clearly see the area of quadrilateral ABDE is the sum of the triangles, is sum of the area of triangle ABE. So we have area of AB DE is equal to area of triangle ABE plus area of triangle BED. Area of triangle ABE we have found to be 10 and area of triangle BED is already given to be 40. So it will be this much meter square, which is equal to 50 meter square. So the area of the quadrilateral ABD is 50 meter square. Okay. and the ratio of the area of quadrilateral ABDE and triangle BCD is given to be 5:2. So definitely we can then find the area of triangle BCD. So we have area of ABDE divided by the ratio, that is ratio of area of quadrilateral ABDE and triangle BCD is given to be 5/2. This ratio is given. So this implies that area of triangle BCD will be equal to 2/5 multiplied by area of quadrilateral ABDE. This is equal to 2/5 multiplied by area of quadrilateral ABDE is found to be 50 meter square. So this is equal to 20 meter square. Okay. So area of triangle BCD is 20 meter square. Now we also know that the area of triangle BCD is half multiplied by the base BD multiplied by HC is equal to 20. So this will imply half multiplied by BD multiplied by HC is given to be 3 meter. So we have this. So from here we can easily solve for BD. BD will be 20 multiplied by 2 divided by 3. This is 40/3 meter. So the length of the BD is 40/3 meter, and hence the correct choice is D. The correct choice is D. Okay, let's do the last problem, that is question number 5. So a figure is given. ABCD is a quadrilateral whose diagonals intersect at 90 degree. Whose diagonals intersect at 90 degree at the point O. It is only intersecting, it is not bisecting, it is only intersecting at right angle at the point O. If BO is equal to 2x, OD is equal to 7x, and area of ABCD is 18x square, then the ratio AC is to BD is AC is to BD. BD we know is 2x plus 7x. Okay, then we have to find the ratio of AC is to BD. AC. Okay, if the area of the entire quadrilateral is given. Okay, so let me draw the figure. So we are having this kind of quadrilateral where the diagonals are intersecting at right angles. Okay, so we have A, B, C and D. This is 2x and this is 7x. They are intersecting at O. Intersecting at O. Okay. AC and BD. Okay. Area is given. Now since the two diagonals are intersecting at right angles, it will be easy to find the area of the quadrilateral ABCD. Okay, so let's okay, so let's find what is the area. So we can see that area. Okay, let's find what is the area of triangle ACD. In the triangle ACD, in triangle ACD, we see that OD is perpendicular to AC. OD is perpendicular to AC. So we can consider AC as the base of the triangle ACD and OD as the height. So area of triangle ACD will be half into base, that is AC multiplied by its height, that is OD. This is equal to OD is given as AC multiplied by 7x by 2. OD is 7x, this is this, okay. Similarly, in triangle ABC, we can see that OB is perpendicular to AC. So we can consider AC as the base and OB as the height. So area of triangle ABC will be equal to half the base AC multiplied by the height OB. This is equal to, OB is 2x, so AC multiplied by 2x divided by 2. Okay, so now the area of the entire quadrilateral ABCD will be equal to the area of the two triangles, that is triangle ACD plus the area of triangle ABC. This is equal to, area of triangle ACD is 7x by 2 multiplied by AC, and the area of triangle ABC is 2x by 2 multiplied by AC. We can take AC common and see we have 7x by 2 plus 2x by 2, which after simplification will be 9x. 7x plus 2x is 9x by 2. So this is the area of the entire quadrilateral ABCD, which is given to be 18x square. So this implies that AC multiplied by 9x by 2 is equal to 18x square. Okay, so from here we can get AC in terms of x. So AC will be equal to 2 multiplied by 18x square divided by 9x, which is equal to, after simplification, it will be 4x. So AC is 4x. Okay, we already know BD is, okay, we have to find the ratio of AC and BD. So this implies AC by BD is equal to 4x. What is BD? BD is BO plus OD, that is 2x plus 7x. This is 4x by 9x. This is 4 by 9. So this implies that AC is to BD is equal to 4 is to 9. So the ratio should be 4 is to 9, and hence the correct choice is D. The correct choice is D. Okay. I'm sorry for problem number, which problem it was? Problem number 2, not 2. Which was it was? Which one? Problem number 2, that I could not match with the choices. Either the given information is wrong in the problem, that is the ratio, the area of the isosceles trapezium, or the choices are given wrong. Anyway, the more important thing is to understand what the problem and how to approach the problem applying the concept properly. So this was 5 relatively harder problems. This should provide a good practice of the concepts of finding area of polygons, that is quadrilaterals, trapeziums, regular polygons, irregular polygons, and even also triangles, squares, rectangles, all these polynomials. So this brings to an end in solving the 5 good problems of set 1 on the chapter of area of polygons. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. Now, one thing I will always say, that whenever you are solving any problem, set of problems, either it is from your exercise problems from your test book or any other test or any other reference book, always look over the solution and all the concepts that you have applied to solve the problems, and revise those concepts. Take half an hour or as much time as required to go over the concepts applied once again and note them down in your notebook. The more you do this, the more the concepts will be in your mind for a longer period of time. I will not do that as it will make the video longer. But please do this every time you solve a set of problems. I will end the video here. Thanks for watching, and until the next video, take care and bye.